These sunglasses aren't because of a fashion decision, but because the data we're going to look at is hard to endure. Behind today's assessment stands Emory Healthcare, one of the Southeast's leading medical systems, serving countless communities with cutting-edge technology, research, and life-saving care. But even positive and helpful institutions can leave permanent and lasting scars on the environment. When we look at the data, the environmental drawbacks are impossible to ignore. According to a report by Emory Healthcare, every year, Emory uses over 272 million kilowatt hours of electricity, which is enough to power 26,000 homes. Its central steam plant consumes 786 million cubic feet of natural gas annually, which is enough to fill 21 Empire State Buildings. Even after a 14.8% reduction in energy use over the years, the remaining environmental load is still critically high. And this matters because sustainability in healthcare isn't just about carbon, it affects access, affordability, and patient experience. Many patients still face high costs, limited providers, long wait times, and a lack of awareness of available healthcare resources. So the question isn't whether Emory should improve, it's where change would matter the most. Most people assume lighting is negligible. In reality, it can account for up to 40% of a building's energy use. Enter solution 1. Emory could significantly reduce waste by upgrading to LED lighting, improving insulation, sealing air leaks, installing double or triple glazed windows, and using reflective roofing materials. Triple glazed windows can be implemented on the east and west side of the buildings to ensure maximum effectiveness. Lighting improvements alone can reduce lighting energy inputs by 20 to 40%. A smart first step would be a full energy baseline assessment modeling savings versus cost before campus wide implementation. This assessment should include thermal imaging, lighting audits, and utility bill analysis to quantify inefficiencies and identify high impact intervention points. This graph shows the efficiency levels of double and triple glazed windows in respect to regular windows, with triple glazed windows being 20% more efficient than double glazed windows in terms of energy efficiency of the building. Enter solution 2. HVAC systems are one of the largest energy consumers in hospitals, especially when they're outdated or poorly optimized. Emory can upgrade by installing variable frequency drives, which help enhance energy efficiency and control motor speed for various applications, including fans, pumps, and compressors, and switching to high efficiency chillers and heat pumps that have a SEER rating of over 23, which Emory is not transparent on. Adding rooftop solar or geothermal systems to offset peak demand could further reduce energy use while improving indoor air quality for patients. This graph shows the amount of energy saved by different HVAC systems, with the geothermal system saving 80% of total energy input. But energy waste isn't even the most shocking part, because the real environmental problems at hospitals is the things you cannot see, the waste. According to the Emory Wheel, Emory only diverts around 51% of waste from landfills. Emory struggles with proper separation of hazardous and non-hazardous waste at the point of disposal. That means non-hazardous waste is sometimes treated as hazardous, wasting massive amounts of energy, while hazardous waste can slip into general landfill streams. The solution starts with mandatory staff training, food donation programs for edible surplus, and material reuse during facility upgrades including metal, glass, wood, and concrete. A very local food donation center called the Davis Street Food Pantry donates around 180,000 pounds of food each year. If we scale that to the side of Emory Healthcare and all its infrastructures, the results will be significant and definitely address some aspects of regional food insecurity. Emory should also require contractors to meet 75% construction and demolition waste diversion standards, meaning most materials are reused instead of landfilled. Transitioning from incineration to autoclaving or microwaving waste would further reduce emissions and energy use. Autoclaving uses pressurized steam to sterilize medical waste. Autoclaving releases zero carbon emissions, with incinerating releasing 1.2 mg of CO2 per mg of material burned. The milestones of this project are broken up into four main parts. The first stage will consist of implementing ideas and identify potential problems. The second stage consists of implementing HVAC systems and new lighting efficiencies with better waste management solutions. The third stage consists of maintaining implementations, and the last stage consists of expanding such new implementations to other infrastructures with the help of new partnerships with different NGOs. Together, these changes will reduce landfill contributions, environmental risk, and help Emory meet its long-term sustainability goals. For Emory Healthcare, this wouldn't just be another environmental reform. It would serve as a strategic investment for the reputation. Lower energy costs free up to $3 million dollars that can be reinvested into patient care, insurance access, and community programs. A cleaner environment improves patient experience, strengthens public trust, and reinforces Emory's position as a transparent, responsible leader in healthcare. With the resources, influence, and responsibility it holds, Emory Healthcare has the power to enforce measurable impact from just a couple decisions. Emory, the choice is yours.